Hello, this video is to go over the practice midterm. Part 1 is the multiple choice problems, so we will go right ahead and start with number 1. In number 1, we're finding the product of two binomials, so we want to create a box for ourselves and do some multiplying to fill inside. We have 2 over 5x minus 3 over 4y squared multiplied by 2 over 5x plus 3 over 4y squared. Right away I'm noticing that these two are conjugate pairs, which means that when I multiply these, my two diagonal boxes should cancel each other out. So these should end up combining to be 0 if I do this correctly. But we'll go ahead and see if that is actually what happens on here. Move that away for now. And we're going to go ahead and multiply 2 fifths times 2 fifths, 4 over 25. X times x is x squared. When I multiply a negative times a positive, I'm going to get a negative. 3/4 times 2 fifths is going to give me 6/20. And I have xy squared. 2 fifths times 3/4 is going to give me a positive 6 over 20, and I also have xy squared. And then a negative times a positive is going to give me a negative. 3/4 times 3/4 is 9/16, and I end up with y to the 4th. And if you notice, these two are positive and negative same terms, so they will cancel out. And we have left 4 over 25x squared minus 9 over 16y to the 4th. Our solution is number 1. Moving on to number 2, if I'm going to add two fractions, then I need common denominators. And let's go ahead and get rid of this extra writing here, get it out of our way. And back to number 2, if I need common denominators, then I want to look for what the best common denominator would be. Here I've got 2y minus 6, and then I have 6 minus 2y here. Almost the same, only opposite signs. If I change, or I want to have a 2y minus 6, I could factor out a negative 1 out of my second fraction denominator. Then, bringing down this first fraction and factoring out a negative 1 out of the second denominator, I could make this 2y positive and the 6 negative. Now I can see that the 9 over the negative 1 would become a negative 9. So in other words, I'm dividing 9 by negative 1 and I'm getting negative 9. So I'm really simplifying this to be 1 and this a negative 9. So I'm going to rewrite this again. I get 3y over 2y minus 6 plus a negative 9 over that same denominator. Now that I have equivalent denominators, I can combine these two when we're adding fractions. We want to keep our denominator, combine the numerators, 3y minus 9, and then see if we can simplify this. In the numerator, I have a common factor of 3, so I can factor that out and get 3y minus, 3 times the quantity, y minus 3. In the denominator, I can factor out a 2, and I get 2 times y minus 3. Now notice that I have binomials that are exactly the same and they're factors, so I can divide those and get 1, and my final simplification is 3 over 2 Answer's number 3. Moving on to number 3, we have a parabola given this focus point and a directrix. So we can go ahead and find which equation represents that parabola. Since this is multiple choice, you could, if you wanted to, graph each one of these on your graphing calculator and see which one has the focal point of 0, 3 and the directrix y equals 6. I'm going to go ahead and do this algebraically so that you can see how this would be done. I want to draw myself some axes, so give myself some lines right now. And let's see. There's my x and y axis. And I can plot this focal point at 0, 3. So I'm going to estimate that 0, 1, 2, 3. There's my focal point. And I have a directrix at y equals 6. So it looks like I'm going to have a directrix 3 units above that focal point. Somewhere over here. Trying to extend this line here, not working for me very well. We'll just move it like this. And so I will have a vertex that's going to be exactly in between those 2 points, right between 3 and 6. That would be at 4.5. So my vertex, 0, 4.5. And this thing is going to need to open downwards, something like this. Alright, we've learned a couple different ways to get the equation for this. The first way that I will solve this is using the first method that we used before. So, method number 1. I want to pick a point randomly, call it point xy, and write my distance from that point to the focal point. We'll call that d1. d1 is going to be using the distance formula. The difference between x and my focal point 0. Hang on here, I should have written a subtraction sign here, and a square root. So I'm using the distance formula here. Distance d1 will be x minus my focal point coordinates of 0, 3. So my x coordinate there is 0. Quantity squared plus y minus 3 quantity squared. And we want to set that equal to the distance to our directrix here. Call that d2. X values will be the same. So I would have an x minus x squared, which will end up being 0. And the y values will be y minus my 6, which is the y coordinate at this point here. So now when I simplify this, I get x minus 0 or x squared plus y minus 3 quantity squared and all that under the radical sign equals x minus x is 0 squared and y minus 6 squared. So if I square both sides, then I get x squared plus y minus 3 squared equals y minus 6 squared. And I want to go ahead and multiply these out. I'll get y squared minus 6y plus 9, and y squared minus 12y plus 36. When I go ahead and combine my like terms, I'm going to subtract y squared from both sides, which will make these cancel out. I'm going to end up wanting to get y on one side and everything else on the other side. So I'm going to go ahead and add 12y, move all my y's to the right side, and move everything else to the left side. So I'm going to subtract an x squared from both sides, and subtract 9 from both sides. And I will end up with negative 6y plus 12y gives me 6y. And on the right hand side, looks like I've got a negative x squared. And when I combine my 36 minus 9, we get a positive 27. Now I need to divide everything by 6. And I get y equals negative, call this 1 6 times x squared plus 27, which is solution number 4. The other method, which I will go ahead and go through, so method number 2. Not sure I'm going to have enough space here. Let's see what we can do. So method number 2 involves using our formula y equals 1 over 4p x minus h quantity squared plus k, but I need to make sure I take care of my leading coefficient, or the sign of that. Knowing that this parabola opens downwards, I will need this to be a negative 1 over 4p. And remember now that h is our x-coordinate for the vertex. So if my vertex is at 0, 4.5, then we know that h equals 0, k equals 4.5, and I need the value of p. P is the distance between the vertex and the directrix, or the vertex and the focal point. In this case, p is going to be equal to the distance between 0, 4.5 and 0, 3. That would be a distance of 1.5 units. Alright, so knowing that, I can substitute those into my equation. And I would use y equals negative 1 over 4 times p, which is 1.5, times the quantity x minus h is 0, and k is 4.5. Cleaning that up, I get y equals negative 1 over 6 times the quantity x squared plus 4.5. Now this is an equation that's in standard form. Does not match the standard form equations in my choices number 1 or 2, so I know that those aren't my answer. But if I didn't already know the choice answer was 4, I would need to rearrange this equation, and I would, let's see, just rewrite this up here. 4.5, I'm going to change to a fraction value of 9 over 2. And if I want to have 1 over 6 as a common factor on the outside of my parentheses, I would need to divide 9 over 2 by my 1 over 6. Or I could maybe make it a little easier if I rewrite 9 over 2 as a fraction that's got this common denominator of 6. And to do that, I would multiply numerator and denominator by 3, so that I get 9 over 2 equals 27 over 6. So now if I substitute 27 over 6 in for 9 over 2, y is a negative 1 over 6x squared plus 27 over 6. Now it's a little bit easier for me to factor out that negative 1 over 6. If I do that, I get an x squared and a minus 27. And then I know that my answer is, number 4, except that they didn't factor out a negative. They factored out a positive 1 over 6. So here's what we get. Putting the negative sign back in. All right, should be good to go. Moving on now, we are on number 5. Number 5 wants us to come up with an equivalent expression. If you take a look at what you've got here, this is very close to what we get when we are in the middle of doing some factoring. Look what happens if I put here a negative, not just a negative and then parentheses x plus 2, but make this a negative 1 times this x plus 2. Same thing as we have originally, only we're putting that 1 in. And so now you can see that we have common binomials here. So I can write that one down. This is part of the process that you do when you are factoring for terms. Now I can look at this and say this is difference of two perfect squares. I can factor that further. Bring down my x plus 2. And I can see that there are 3 binomial factors. Also, if you notice on this thing, this should end up becoming a cubic function. So I should be able to eliminate 1 and 2 right off the bat. Let's move on now to number 6. We've got a quadratic equation here. We want to find the roots, or in other words, the solutions. So one way that I can do that is to use the quadratic formula, or completing the square. When I look at my choices here and I see these radicals, that means this is not a quadratic that's going to be factorable. It doesn't give me nice whole number solutions. So I'm going to go ahead right off the bat and use the quadratic formula. This is already in standard form, so I can pick out my A, B, and C values pretty quickly here. And when you do this, make sure your equation is in standard form. Alright, so I'm going to use my quadratic equation. This, by the way, is given to you on your reference sheet, so you don't have to worry about memorizing it. I want to simplify this now. First, I want to take this, throw it in my calculator, and I would get x equals 3 plus and minus the square root of a negative 19 all over 2. Notice that I've got a negative under the radical sign, so I'm going to get an I value, and I will get I radical 19 all over 2 here, and radical 19 cannot be simplified, so my solution is number 2. Moving on now to number 7. We have 2x squared minus 2x cubed minus 5x, but I am missing any x squared terms. So I'm going to put in a placeholder there, move this over, and then go ahead and fill in 0x squared, and then my minus 5x plus 4. I want to divide all of this by x minus 3. Okay, so I'm going to go ahead now and think about what do I multiply x by to get 2x cubed, and that would be 2x squared. I'm going to multiply that by both my terms here, and I get 2x to the third power plus 6x squared. I'm going to subtract this polynomial, so I need to distribute a negative sign here and here, and then treat it like I'm adding vertical terms. Those will cancel out, and I will get, hang on, 2x squared. I should have gotten a minus here. Changing my sign, then I would get a plus. Adding these together, I get a 6x squared. Alright, so just to review how that happened. 2x squared multiplied by x gives me a positive 2x cubed. 2x squared multiplied by a negative 3 would give me a negative 6x squared. Then when I distribute my negative sign, this becomes a positive 6x squared. So now I'm adding my terms together. I get 6x squared, and I'm going to bring down a minus 5x. And I want to think about what do I multiply times x to get 6x squared. And I would multiply this x by positive 6x. And now when I multiply 6x times x, I get 6x squared. 6x times a negative 3 gives me a negative 18x. I need to subtract that, so I'm going to distribute a negative sign. And then add to what's above it. 6x squareds cancel out. Here we get 13x. And I'm going to bring down the plus 4. And what do I multiply x by to get 13x? I multiply it by 13. So I get 13x here and a negative 39. Distribute a negative sign. Add vertically, and I get 43 here, which is my remainder. And I'm going to write that as plus 43 over x minus 3. The answer is A. Moving on to number 8, we have a graph. Looks like it's a cubic function. Could be a fifth degree. But they're asking us what the remainder is when we divide by x minus 4. We don't know what the polynomial expression is. But if x minus 4 is what we're dividing by, then a solution, if it were a solution, would be x equals 4. So I'm going to go and look on my graph at when x is 4. 1, 2, 3, 4. When I put an input of 4 in, looks like my output value on the y-axis is 9. So my point here is 4, 9. There's my remainder. Answer is number 4. All right, moving on now to number 9. We have a radical equation. When we have radical equations, we want to make sure we rearrange if we need to, so that we have a radical expression all alone on one side of our equal sign. So it looks like we have a radical sign, nothing being added or subtracted, multiplying or being divided. It's all alone on one side of our equation, so we can go ahead, no rearranging to do. We can now take entire sides and square each side. That makes our squaring cancel out our radical sign, and we get 5 minus 2x equals 3i squared is 9i squared, or negative 9. And now I just need to solve for x, so I'm going to subtract 5 from both sides. Negative 2x equals negative 14. and we get x equals 7. Now remember, with radical equations, we always need to check our solutions. So I'm going to substitute this 7 back in for x in the original equation. 5 minus 2 times 7. We want to see if that equals 3i. We get radical 5 minus 14, which is radical negative 9. And the radical negative 9 is indeed 3i. So that checks. And x equals 7 is our solution. Okay, moving on then to number 10. We want to completely factor this polynomial. So my first step for factoring is to look for a GCF. And let's see, 3, 5, 48, and 80. 3 is my smallest number, but 3 does not go into 5. So no GCF that's a constant. Let's look at x's. First 3 terms have an x, but the fourth term does not. So no common factor, no GCF. Next thing I want to do is count terms. I see that there are 4 terms, which means I want to factor by grouping. So I need to write those 4 terms out and then divide them into groups of 2. 3x squared minus 5x squared, 3x cubed minus 5x squared. There's one group of 2, minus 48x plus 80. When I look for the GCF of my first 2 terms, that would be x squared. And I multiply that times 3x minus 5. GCF of my next 2 terms. Well, 48 and 80 have a common factor of 16. And I'm going to factor out a negative 16 so that I get a positive 3x minus 5. Since my binomials are matching, I'm going to write that binomial down. And x squared minus 16 is my other factor. Now this answer matches number 1, however it is not completely factored because this is difference of 2 perfect squares and can be factored some more. X squared minus 16 can be factored into x minus 4, x plus 4, and we have our 3x minus 5. So our solution then is number 3. Just looking at the other solutions, there's a couple we can eliminate off the bat. This polynomial that we're factoring is a third degree polynomial. Number 1, if we were to multiply, is a third degree, but it's not completely factored. Number 2, if I were to multiply this out, an x squared and an x and an x, this is a fourth degree. Doesn't match what I started out with. And number 4, if we were to multiply that out, that is also fourth degree. So we should have been able to eliminate actually all of those without even completely factoring ourselves. Alright, well let's move on. We want to take a look at number 11. And this thing is another polynomial, and they want us to completely factor. If I'm looking for a GCF, I can see that, there is no GCF there. A is not in every term, and the smallest coefficient is 1. So that's not going to help us at all. So no GCF. And when I count the terms, there's 1, 2, 3, 4, 5, 6 terms. I don't have a process for factoring 6 terms. However, we could try and see if we could factor by grouping. So I'm just going to go through the process, divide this into groups of 2, and see if I can factor this trinomial. First 3 terms here, there is a GCF. That would be a squared. If I factor out an a squared, I get a squared minus 6 minus 2a, not exactly in order from highest degree to smallest. Let's see what happens if I try and factor now. Find a GCF out of these next terms. 7a squared, 14a, and 24. No number that's a GCF, and no a and everything, so really can't factor. So I'm going to stop trying to factor by grouping at this point. You actually could if you did some rearranging, but we're going to figure out how we could proceed from here without continuing to try and rearrange. If I take a look at all of my values here, and I'm going to do some erasing here. My constant in this original polynomial is 24. So in order to have my factors end up with a plus 24, if I were to multiply all of my constants with the signs here, I want to find one that ends up equaling a positive 24. So if I look at number 1 and I multiply positive 1 times negative 2 times negative 3 times positive 4, that one does give me a 24. If I look now at the next one and I multiply plus 1 plus 2 minus 3 and plus 4, I'm going to get a negative constant, not a plus 24. So I can just eliminate that one. If I look at number 3, plus 1 minus 2 plus 3 minus 4 does give me a 28, or excuse me, 24. So I want to keep that one. And if I look at the fourth one, positive 1, negative 2, negative 3, negative 4, that gives me a negative 24. So I'm going to eliminate that one. So I'm looking now at numbers 1 and number 3 as possible solutions. I'm going to erase these so that I can see them a little bit more clearly. Alright, if I look at these, both have factors of a plus 1, and both have factors of a minus 2. The difference is in the a plus 3 versus a minus 3, and the a plus 4 versus the a minus 4. So because they have these two common factors, I can assume that these parts are correct. And if I multiply those two together, I get a squared plus 1a and a minus 2a becomes a minus a, and plus 1 times minus 2 becomes minus 2. This is definitely a factor of a to the 4th minus 6a squared, this whole thing. What I want to do is divide that whole thing by this factor that's a squared minus a minus 2. However, I want to combine some like terms so that I can go ahead and do my division. So I notice that there's only one a to the 4th term, so that's going to remain the same. However, I want to find a cubes. There's only one a cubed term, and that's this minus 2a cubed. So I'm going to put that next. My a squared terms are negative 6a squared, negative 7a squared, which gives me altogether negative 13a squares. And then I have this 14a and the plus 24. That's my polynomial after I've combined all like terms. What I want to do is take that polynomial and I want to divide it by my known factor of a squared minus a minus 2. So I'm going to go ahead and set up that division. And in order to figure out what my first term is going to be, I need to think, what do I multiply a squared by to get a to the fourth? That's a squared. And I'm going to take that a squared and multiply it by every term. A to the fourth minus a to the third minus 2a squared. I want to distribute a negative sign and add vertically. Those will cancel out. Negative 2a cubed plus an a cubed leaves me with a negative 1a cubed. Negative 13a squared plus 2a squared is going to give me a negative 11a squared. And I want to bring down 14a. Now what do we multiply a squared by to get negative a to the third? We multiply it by a negative a. And I've got to multiply negative a by all my terms. Negative a times a negative a gives us positive 1a squared. And negative a times negative 2 gives us a positive 2a. I need to distribute a negative sign. And add vertically. Canceling out these, negative 11a squared minus 1a squared, negative 12a squared, and 14a minus 2a plus 12a, bring down our 24, and a squared has to be multiplied by a negative 12 in order to get negative 12a squared. And we get a positive 12a and a positive 24. Distribute a negative sign. Add vertically. Everything will cancel. So we have a squared minus a minus 12 as another factor. And we can factor this further. 3 terms. We want them to add up to a negative 1. Multiply to negative 12. That would be a negative 4 and a positive 3, which means that this could be factored to a minus 4, a plus 3. That is solution choice number 3. So correct answer for number 11 is 3. Moving on now to number 12. We want to figure out what is xy squared z equal to. Well, x is equal to 3i, so we're going to substitute in 3i. Y is equal to 2i, but y needs to be squared, so we're going to have to square that, and z is equal to m plus I. So we need to simplify this as much as we can. Let's do exponents first. 3i is our first term, but 2i has to be squared first, giving us 4i squared. And then we've got multiplied by m plus I. Alright, I need to change my I squared to be a negative 1. So we're actually going to multiply that and get a negative 4. Now as I multiply 3i times a negative 4, I get negative 12i, and that's multiplied by m plus I. Now I've got to distribute the negative 12i, negative 12mi minus 12 with an I squared, but we're going to replace our I squared with a negative 1, which means that I'm multiplying negative 1 times 12, getting a negative 12, but when I subtract it, it's as though I'm adding. So looks like I get, in a plus bi form, 12, positive 12 first, minus 12 mi. 12 minus 12 mi, that's number 3. Alrighty, moving on to number 13. I want to figure out what's the conjugate of negative 1/2 plus 3 over 2i squared. Remember, conjugates would be forms that are a plus b and a minus b. So my first term has to be exactly the same. If I start out with a negative 1/2, that's my a. And if one term is plus 3 over 2i, then b is equal to 3 over 2i, and I want a minus 3 over 2i. So the conjugate is negative 1/2 minus 3 over 2i. That is answer number 4. All right, moving on. We want to take a look at x to the 4th minus 3x squared equals 4, and we want to find all of our solutions to that. That means that I probably want to do some factoring. So if I'm going to factor, I need everything on one side of my equation. X to the 4th minus 3x squared. I need to subtract 4 from both sides. So I get this thing equaling to 0. And then the next thing that I want to do is count my terms, look for a GCF first though, but I know there's no GCF. So 3 terms. I'm going to try x factoring. I want two numbers that add up to negative 3 multiplied to negative 4. Let's see, that would be negative 4, positive 1. So I need to, so you see where this is coming from. I need to end up with an x to the 4th. And it looks like I'm going to have x squareds on the outside here. And when I add up my two terms, x squared terms are going to add up to negative 3. Here's where I have a negative 4 and a positive 1 from my x factoring there. So this would give me a negative 4x squared and a positive 1x squared. And when I combine those two together, I get negative 3x squared, matching my middle term here. And my last piece of the box here will be a negative 4, which is what I wanted here. So my factoring looks like it's x squared minus 4 multiplied by x squared plus 1. But those can be factored even further. X squared minus 4 is difference of two perfect squares. So we have x minus 2, x plus 2. X squared plus 1, sum of perfect squares, so we're going to have some imaginary terms. Erase some of this and give ourselves some space here. Imaginary terms are going to involve an I, x plus 1i, and x minus 1i. So there's the factors. When I turn these into solutions, I'm going to have 4 solutions. 2 are real, and 2 are imaginary. So my solutions are positive and negative 2 and positive and negative I. So number 3 is our solution. All right then, we are moving on one more problem in our multiple choice. Number 15, we have a graph f of x. We want to know real solutions. Well, real solutions are x-intercepts. So it looks like there's 3 real solutions at x equals negative 2, x equals 0, and x equals 3. Not too hard at all. So it looks like number 4 is our solution. And we are finished with our multiple choice. We're going to end this video and start a second one that has the part 2s, 3s, and 4s done.